Imagine you are packing for a camping trip. You have a single backpack and a pile of essential, highly valuable items. The problem is they are too heavy to all fit inside. Environments with limited capacity are called the knapsack problem. Mathematically, it has 4 strict components: N, available items; W, item weight; P, item profit; and M, the bag's capacity. This exact model applies to allocating hard drive gigabytes or a limited financial budget. Any situation where you must choose between competing, valuable items to fit inside a strictly limited resource is a knapsack problem. To play this game, we have 2 rules. First is our primary objective. We want to yield the maximum possible total profit. Second is our hard constraint. The combined weight of these items must never exceed our capacity. Balancing this desire for maximum profit against a rigid physical limit is what makes this an optimization problem. These optimization problems split into 2 distinct universes based on a single question. Are you mathematically allowed to break an item into smaller pieces? In the fractional knapsack universe, items can be divided. Like pizza, you can take half the weight and get half the profit. In the 0-1 universe, items like a laptop cannot be divided. You either take the whole item or lead it entirely. Knowing whether you are in the divisible pizza universe or the indivisible laptop universe dictates the mathematical approach you use to find your solution. A beginner's instinct is to use a greedy approach and simply pick the item with the highest total profit. Let's look at this comparison between a heavy gold bar and a lighter diamond. Pause here for a second and calculate. Which item provides more value if you only had exactly 1 kilogram of space left in your bag? We divide total profit by total weight. For gold, 100 divided by 10 gives 10 per kilogram. For the diamond, 50 divided by 2 is 25 per kilogram. Despite a lower overall profit, the diamond is far more valuable per unit of space. This profit-to-weight ratio is the ultimate criterion. It's the exact mechanism our algorithm uses to evaluate an item's true worth and guarantee an optimal answer. Here is the formal academic definition. The fractional knapsack problem is an optimization problem where items with different weights and profits are selected to maximize total profit. Since items can be divided into fractions, the algorithm selects items based on the highest profit-to-weight ratio. For exams, keep these visual shorthand rules in mind. The knapsack represents our strict capacity limit. The pizza means it's a fractional problem where items can be broken down. Our target is maximizing profit, always selecting items by their profit-to-weight ratio. This foundational logic is all we need to construct and execute the step-by-step algorithm. We will run through that entire process in the next video.